Hello guys, welcome back to Chemistry Exams Prep. This is Dr. Kulbhushan. This question is for Mr. Janet, who is doing his master's degree in chemistry from Hanover, Germany. So he asked me to make a few video lessons based on inductive effect and mesomeric effect. So I am going to try to explain these concepts with the help of some questions. So in this question, we need to figure out the order of acidities of these four compounds. So let's name them first according to the IUPAC rules. So this compound has, and all of these compounds have a carboxylic acid functional group. And these compounds are named as alkanoic acids. So if we number this, the numbering starts from the carbon that is part of the carboxylic acid group. So that is meth, eth, prop. So this compound is propanoic acid. Compound B is 2-chloropropanoic acid. Compound C is 3-chloro-2-fluoropropanoic acid, and compound D is 2-fluoropropanoic acid. So these organic compounds are acids because according to Bronsted-Lowry acid-basis definitions, acids are the species that can give protons when they are in solution in presence of a base. Therefore, we can draw the conjugate bases of these four compounds. So let's draw the conjugate bases. It is important to draw the conjugate bases because the more stable the conjugate base, the higher the acidity of the corresponding carboxylic acid. Therefore, for the propanoic acid, let's draw the conjugate base. The conjugate base has a negative charge on the carboxylate oxygen, and there are lone pairs of electrons, 2 lone pairs of electrons on the carboxylate oxygen and 2 lone pairs of electrons on the carbonyl oxygen. So now we drew these lone pairs of electrons and the negative charge to show that this can undergo movement of electrons, and this is known as resonance. So resonance is movement of electrons where the electrons move from one part of a molecular species to the different part. And in resonance, the electrons that can take part are pi electrons or negative charge or lone pairs of electrons. So if we show the movement of this negative charge here, the carbonyl carbon has the oxygen with a double bonded oxygen, so the pi bond breaks and you form the another form, and these forms are called as resonating structures. So the double bond forms now with this oxygen that was carboxylate oxygen. So once we draw these two resonating structures, we can draw the resonance hybrid. where the oxygen gets a partial negative charge, and there is a partial double bond between these two oxygens. So the purpose of drawing this resonance hybrid is to show how negative charge is distributed over the entire molecule, means on both the negative charge is now on both oxygens partially. This resonance is what makes the carboxylate ion more stable, because the negative charge is being dispersed here. And we know that when the charge is dispersed, the species become more stable. And that is the reason that the carboxylic acids are more acidic than corresponding alcohols, for example. Therefore, there is a resonance in carboxylic acids. So now, to answer this type of questions, we need to see the conjugate bases of all of these four species. So we have drawn the conjugate base of species A. Now let's draw for species B. So this is the conjugate base of species B. Then if we draw the conjugate base for C, that would become and for D, the conjugate base would be now we have drawn the four conjugate bases. Now we need to see which conjugate base is the most stable and which one is the least stable, and then we can eliminate some choices which would seem right away incorrect. But before we look at the stability, we need to quickly review the inductive effect, because the concept that is taking part in this question is inductive effect. So inductive effect is an electronic effect, which means that in inductive effect electron movement would occur. There are two types of effects. One is the electronic, the second is steric effect. In organic chemistry, these two effects help us explain several reactivities and stabilities. So this is an electronic effect, and there are two types of inductive effects. First is negative inductive effect, which we have seen in these compounds. So the negative inductive effect is actually when a more electronegative atom takes or group takes away electron from a part of molecule or species, then it is called the negative inductive effect. And the example is in these four compounds. In B, C, and D, there are more electronegative atoms than carbons. So that's why these atoms are taking electron density away from the carboxylate oxygen, and that's what is helping in increasing the acidity of these compounds. So the positive inductive effect is when a group or an atom gives the electrons to a region of molecule or a species. And one of the examples of positive inductive effect would be the stability of carbocations. So if you have a secondary carbocation, carbocations are sp2 hybridized, so the geometry is planar. So this carbon is that has the positive charge is less electronegative than these carbons, because these carbon CH3 carbons are sp3 hybridized. Therefore, there is a movement of sigma bonded electrons from this sigma bond towards the carbon that has a positive charge, and that's why this is called the positive inductive effect, because these two CH3 groups are donating electrons towards this carbon. that bears the positive charge. So this is a secondary carbocation. Another example we can see is a tertiary carbocation. So in tertiary carbocations, for example, if we have 3 methyl groups, then there are more electrons that are being injected towards this carbon that has a positive charge, and therefore the tertiary carbocations are more stable than secondary carbocations, and primary carbocations are the least stable. So the stability of carbocations is tertiary most stable, then secondary second most stable, and primary the least stable. So the stability of carbocations and carbanions are something that are explained by inductive effect if there are no other electronic effect in the molecule or species. So this is the first point. The second point is that the inductive effect is actually the result of the movement of electrons through sigma bonds. This is important because the difference between the resonance and the inductive effect is that in inductive effect the electron movement is through sigma bonds, but in resonance effect the movement of electron or electron density is through pi bonds. So that's one significant difference that separates these two types of electronic effects. Now third point here is that the reason for this type of electronic effect is because there is a difference in electronegativity between sigma bonded atoms. So here we see here that this chlorine is more electronegative than the carbon. So if you see the electronegativity, the carbon's electronegativity on Pauling scale is about 2.5 and Cl's electronegativity is about 3.2, and that's the reason Cl being more electronegative, this shared sigma bond is not there is not equal share of electrons. The electrons are more towards this Cl, and this movement of electrons is shown by this arrow here. Therefore, in this methyl chloride example, the chlorine would get a permanent partial negative charge and carbon would get a partial positive charge. So this effect is a permanent effect because the electronegativities do not change. Therefore, this is a permanent effect. This effect is a compounding effect, which means that if you have one electron withdrawing group versus 2 electron withdrawing groups, the stability of anion would be greater when you have 2 electron withdrawing groups. Now we can see in these cases A does not have any electron withdrawing group, so it does not show any inductive effect. However, here B has one electron withdrawing group, chlorine, and C has 2 electron withdrawing groups. Therefore, the effect of electronegativity in compound C is the greatest. Now, compound D has only one electron withdrawing group. So this effect is actually significantly diminishes when there are more than 3 atoms, and therefore it's a chain effect. It gradually decreases as the distance between the atom that is more electronegative and the less electronegative increases. And so the last points here are their applications. What can we do with the inductive effects? So the inductive effect can explain the polarity of molecules and hence the solubilities. like dissolves like. So the polar molecules will be soluble in polar solvents, and non-polar hydrophobic molecules like benzene would be soluble in non-polar solvents like hexane. It also helps us determine the acidity and basicity of the compounds, and also, as we saw here, the stability and reactivity. We know that the stability and reactivity are inversely proportional. So something that is more stable will be less reactive, and a compound species that is less stable will be more reactive. So we can determine the stability of carbocations, just we saw in this example here. Similarly, we can describe the stability of carbanions and also free radicals. The stability order of free radicals are similar to the carbocations. So now back to the question. So we saw that compound A does not have any chlorine or fluorine atoms, so it does not show any inductive effect. Compound B has chlorine on second carbon, so it would show inductive effect, and its conjugate base would be more stable than that of compound A. Compound D has one fluorine group, and we know that fluorine is, its electronegativity is about 3.9, so that is most electronegative atom in the periodic table. Therefore, compound D would be more acidic than compound B, and compound B would be more acidic than compound A. Compound C, since it has a fluorine group at carbon number 2, so its acidity would be same as D if there were no Cl there. But since there is one Cl as well, so therefore C will be the most acidic compound here, and A would be the least acidic compound. So if we see the options here, we can quickly eliminate some choices. We know now that C is the most acidic. So any option that does not have C at the beginning cannot be our answer. So A is not the correct answer, B is not the correct answer, and D is also not the correct answer, because in D it shows that A is more acidic than B, which is incorrect because B is more acidic than A. Therefore, our correct answer is C.